Hi, today we want to talk about section 1 of Savitch book, the 10th edition, and that would be for chapter 2, and we have about 5 sections over here. We're going to be working on section 1, variables and assignments in this video. So when we're talking about variables, it's just, you can think about it as a placeholder. So it's going to be a number or a character or something that we're going to be calling it, and then it's going to be actually an address in the memory. So if I think about the main memory, remember from chapter 1, the CPU only sees main memory, doesn't see your hard drive or anywhere else. So if I want to run a program, your program has to come in and sit in the memory. Of course, there is no memory out there that's going to hold my whole program. So a piece of my program is going to go and sit in the memory, and then the operating system is going to swap back and forth as needs more stuff. So when my program occupies a section in the memory, it's going to divide that section in 3 places, but we're going to talk about 2 places for today. So one is going to be the code part. That is going to be the actual code. So your code is going to be the binary code, and it's going to be there. And the second part that we want to talk about is going to be your data. So the data is going to be sitting in that section. So you can think about it that as I declare data is going to go and sit over there, and they're going to be just in that order that they are created. So that's where, if we look at this program, or we want to think about it a little further, we can think about it that our data is like containers. So we name them so we can access them. It's going to be easier for us to use it, but the computer is going to look at them as an address. And as my program, I close it and open it, the address changes, but it knows how to go and follow it up. Your assembly class is going to go to detail. So I want to think about this as a container. So if I have something and I want to put it in a container, then I have to figure out which container I can put it, and then I can take it from that container. And that's what we're going to be using the names, so we don't have to worry about it. So in this case, I have a int and a double. We're going to go more detail about it. And they have names. So those names, you can think about it as a label on my jars, that some of them are smaller, some of them are bigger, and they're going to keep those things in there. And actually, that's going to be the size in the memory, and we're going to get to that. Then in this program that you guys did for the homework, you're going to read some things through the variable that you created. So you're going to put stuff in your variables, in your containers, and then you're going to get it out of it. So that's what we're going to be talking about today. And I'm pretty sure you've seen the sample run for this, and we're going to get back and we're going to talk about how we're going to do the sample run for our programs moving forward. So identifiers are the name of the variables. So there is some rules that we're going to be following of how we're going to call them. So the variable, the name has to be meaningful. So we don't want to put A, B, C, D, those kind of things, especially for those who are math major or coming from the math, that, in the math, we have just one character to do things. But here, we want to have a meaningful names. So for example, I'm going to have a student name instead of S or N, because it's easier for me to understand. It's easier for the people in the future to understand my code. So first thing first, when we're creating an identifier, the first thing has to be a character. So the first one, either it's going to be a character, a letter, or it's going to be an underscore. Only these two. You cannot put a number in the beginning or anything else except the character. And I'm talking about this one right here, the first thing that you're going to have. Of course, for our class, we are not going to use the underscore. So we're just going to be having identifiers starting with a character, and it has to have a meaningful name. Next thing, after that character, we can have letters, we can have numbers, or we can have underscore after this. But definitely we cannot have any special character, and we cannot have spaces. So a student name cannot have a space between them. That would be considered two variable names, two identifiers. So whenever we are choosing a name, it has to have a meaningful name. Remember, we are doing small programs here, but in real life, we have tons of programs, and then we're going to be jumping in and out of other people's programs, and people are going to be jumping into our program, and we want to figure it out. So my example is, I was working for EDS. We were doing programs for airlines, the early reservations, and then one of the clients, two of the clients were Virgin Atlantic and British Airways. Their office would open at 8 a.m. So if there was anything wrong, they would call us, which would be 12 p.m. And then we would rotate and somebody would call, and then I pick up the phone and it's 12 p.m. and I got to go jump into all this code and figure out what the problem is and fix it while I'm half asleep. So it's very, very important to have meaningful names for the variables. Then we can use underscore, but we cannot use any special character, as I mentioned already. And there are two types of creating this variable. One that your author start using it in the latest version of the book, the 10th edition, is called camel case. So the camel case is going to start with a lowercase, and every other word after that is going to be uppercase. Previous versions, we were using underscore, and this is something that I was used to it for some strange reason. But either way is fine, but this is what we're going to be using the camel case in this book moving forward. And of course, the names in C++ are case sensitive. That means if I put miles per gallon and I put capital M or any other character that's uppercase, these two are not the same. We do this mistake at the starting of C++. I create a variable called number with uppercase N, and then I go on in my program and I try to use number with lowercase, and I'm going to have a problem. So C++ is case sensitive. So if you declare it in certain case, the convention is you start with lowercase all the time. That's the convention. Then you keep it like that throughout your program. We cannot use the reserve of words. The reserve words are the one that compiler is using, so to identify what's happening in your program. And if you're using a decent IDE, generally it highlights your reserve word. So if I type in double, int, and those kind of things, it's going to highlight it, and then it's a reserve word. I cannot use those for my variable names because it's going to get confused. So some of these reserve word, you might have seen it already as you go through our class, and the next class, you're going to see more of these reserve words. So far you have seen C in, C out, and those kind of things. So when you have a variable, you need to declare it before you use it. So I want to use the analogy of coffee cup. So if I go to a coffee shop and I want to order a coffee, the first thing they're going to ask me is what size. So I have to identify what size do I need. And that goes the same thing with C++. Not only the size, they want to know the type also. So if I'm getting an iced coffee versus the hot coffee, the cups are different. They have different sizes. So that's what the compiler needs to know. So to reserve a space in the memory. And that's one of the reasons that C++ is one of the most efficient language, because it's just going to use as much memory as it needs. It doesn't use it any bigger than that. So in this case, we have int and double. The int is numbers with no decimal point. So if I don't need decimal point, I don't need to occupy that much space in the memory for the decimal point. And double are the ones that are using decimal points. If you recall in chapter 1, it had a picture over there that how the data was stored. And this is the part of data that I mentioned it in the data section of the program, that my data can be different sizes. So if I need 3 bytes versus 2 bytes versus 1 byte, C++ is going to use that much space in the memory. And we don't need to reserve more. So for example, if I go to the coffee shop and they get the extra cup for everyone, and if you want a smaller size, they just put that much coffee in the big cup. Some languages are using that analogy, so they're not as efficient as C++. So the int is going to be, say, integer. It's going to use numbers negative or positive with no decimal points. And then the double, we're going to be using it for the numbers with decimal point, positive or negative. Where do we declare these variables? So you can declare it all the way to the top. That's the way I'm used to it, because I am older programmer. This is what we were doing in C language and got it to C++. So when we are writing program, on top of the program, we would declare all the variables. That way I don't have to worry about it. But in C++, we can declare it when we need it. So if I don't need a sum on the top and I need it somewhere else, I can declare it right there and then. It's not my style. I'm not used to it, but you can do it. And again, I'm going to give you different styles and I tell you about the convention, and then you decide how you want to do it. So we put the what data type we have, int, double, right now. We're going to go through some other ones, and then you can put your variables separated by comma. We can also do it in different lines. So one of the things you're going to be learning in this chapter is you can have one data type at the beginning, and then you can separate the rest of them with a comma. And of course, you need a semicolon to say this is the end of my statement. So in this case, I have 3 variables and a semicolon. Now, I can put them in different lines. So I can have double average, semicolon, double M score, semicolon, double total score, semicolon. And one thing I want to bring up right here, right now, is when you see M score, you kind of can guess what it is, but you really don't know what M score is. That's why your variable name should have a meaning. But when you say total score, you know exactly what is it talking about. When you're talking about average, you kind of have idea what the average is. Or next one, it says double moon distance. So when we're talking about the moon distance, then it's obvious what we're talking about. So we can put them in multiple lines. If I decide to put the data type at the beginning, I have to end it with this semicolon. I can separate them with comma, or I can just put them in different lines. So we don't want to have too many of them in one line. So I don't want to put 15 variable in one line. On the other side, I personally don't want to do one in each line. Sometimes you want to put some comments, and we talk about the comments later on. Maybe you need them to separate, but these are different ways of doing it. So same thing goes with the int, that I am going to put the int at the beginning. Remember, the I is lowercase and the D for double is lowercase. And then I'm going to have age and the number of students here. I like to spell it out. I have switched from C++ to Java, which is going to spell these things out a lot. So, and of course, the semicolon at the end of it. And then the next one is int cars rating and the semicolon. I could put this cars rating at the end of here with the comma, or I could separate all of these things to each separate lines. Next thing we want to talk about is called assignment statement. Assignment statement is going to take whatever is in the right-hand side and put it in the left-hand side. So that means what? We need to have a container, a variable on the left side, and we can have only one. We cannot have multiple of them. On the right side, you can have one thing, or you can have a total statement. So if you have some kind of a calculation, it does that calculation and then assign it. If it's just one thing, it's going to take that one and it's going to assign. So in this case, we have some age equal 21. So I can just put number 21 in age. So you can think about these things as a container. So I take the number 21 and I put it in the container age. And in my cost, I'm going to put another variable. So if there is a variable on the right side, it's going to take the content of that variable and put it on the left side. And if I have some kind of a calculation, it does the calculation on the right, then it puts it in the left. So everything on the right is going to happen, then it's going to assign. Most of you have seen this if you have done your homework. So this is an equal sign. And then because we're doing the right side first, then we're going to go to the left side. We can do this, meaning that I'm using my variable name on the right side and the left side. So let's say number of bars, I already have 5 in it. It's going to take that 5 that I already have. It's going to add 3 to it, that becomes 8, and it's going to go put it back. So the 5 is going to be replaced with 8. So this is the way we're going to be declaring a variable. And remember, we have to declare the variable before we use it. Now, in C++, when you're declaring a variable, that does not mean you're putting something in it. So some languages like Java would automatically put default value in them, but C++ doesn't do it. So when I say double MPG, that MPG is not empty. And later on, I'm putting a number in it. We can declare and initialize at the same time. So coming in from the C language and declaring everything on the top, we were used to do the default values in it. Why do we want to do that? Of course, there is another way of doing it. So that's 2 ways of doing it. Now, let's go look at a very, very simple program. So I am debating, and okay, if I have a double MPG and it says that declaring variable does not give it a value, is that really true? And what is it going to be there? So I wrote a simple program. Let me clear these things. So I wrote a simple program. This is a C line. Let's go and we can change the format. So it's going to be easier to read. So if I go to appearance, I can go to the presentation mode. I can go to the full screen. But one of the things that I want to do is I can go to the file. I can go to the setting, and I have all kind of stuff for my setting. One of the things that I have in here for my editor, let me see. So in for the general editor, we can change the font. We can define how we want to do the coding. We can do the appearance. So right now it's defined the theme as Dracula. So I can change it to, let's say, Windows 10 Lite to make things lighter for you guys to be able to see it. So that's the things we can do in configuration. So that might be easier for you guys to follow and see. So I have this program. I want to say, okay, if I create a variable, and that variable, what is it going to have in it before I put something in it? So I'm going to print it to see what's going to happen. I'm not just going to print it by itself. I want to have some kind of a wording so it makes sense. What is it printing? So I'm going to say number of books before entering, and then I'm going to print that one. And then I'm going to say enter a number. I'm going to get a number from the user, and I'm going to put it right here. So when I try to run this, remember why I set my CLIN that whenever I run, it's going to compile, save my file, then it's going to run. So it's going to do compile it. It's going to first it's going to save my file. It's going to compile it, then it's going to run it. So I'm going to run it. Basically, I want to compile it. And then on the bottom window, I am looking at an error. So it says error, and it says expected semicolon. It's showing me where it thinks it's supposed to be. So it says it's going to be after this, and it's going to be in line 7. I can click on this, or I can go to line 7. Or when I'm looking at my code, it is red over here. That means something is wrong. So when I'm looking at my code and I see red over here, that means something is wrong. I'm going to go over it. It says there is a semicolon is missing. So yeah, it is trying its best to tell me what the problem is. So when it says semicolon is missing, I'm looking around. Okay, this line has a semicolon already, but the one before it, it doesn't have a semicolon. If I look at the main, that the CPP line 7 here is giving me semicolon needed. And if I click on that link, it's going to take me over there. So that means what? I am missing a semicolon. So I'm going to put there, and I'm going to try it again, see what happens. Okay, I have another one. The problem is no match operator. So it's complaining in line 8. It says this operator over here is not correct. Why is that correct? Because my cout operator is this way. The cin cannot be this way. The cin is supposed to be the other way around. So I'm showing you to follow the errors that you get and try to fix your issues. It's trying its best to give me the best thing possible. Okay, so I did that. I'm going to try to compile it again. Okay, now it compile and run. So you can see that the number is 4,200,331. So when I declare this variable over here, number of books, C++ put this number in it. That's what it was in the memory before we ran this. So that's the number in here. So if I take that one and I use it in a formula on the right-hand side, it's going to use this number. It's not going to use 0. And that's why initialization of your variables are very, very important. So let's put something in. So I'm going to put, let's say, 5 in. Now I'm going to enter, and it says the number of books now is 5. So after I put something in it, its value has changed. Another thing that I wanted to do, and this is what I encourage you guys to do, just try it out, try it out, try it out. I said, okay, where does this number come from? Is it possible that my integer doesn't take this, is taking its maximum number of integer? So I'm digging into it and say, okay, what is the maximum number of integer? So I go and figure it out somewhere that the max integer is called a variable called int max. So I want to know what is the int max in my computer. So if I run this, it says that if I don't put any number in my variable, it's going to have this number, 4,200,283. But my max number, the highest number I can have, remember, computers are finite place. They don't have unlimited space. So the space that it's reserving for integer in my computer, which can potentially be different than other computers, can hold this number in there. This is the maximum it can do. So if I add 1 to it and try to put an integer, it's going to go totally wrong. I cannot go beyond this. That's the maximum I can use it because I'm using a 64-bit machine. When it was 32-bit machine, it was much smaller than this. So just play around things, bring it up. Let's talk about it in the chat, or let's talk about some experiences that you have, and then we can talk more about it. So be sure, especially if you're using your variable on the right-hand side, that you initialize it. Otherwise, it's going to just get that big, huge number. And try it out, see what happens with yours. This is the activity we're going to do in your class next week. Be ready to talk to your classmates and the class as a whole, so we can do this one. And this is going to terminate the section 1 of chapter 2.